Alright, so we want to, in this example, show you how to find and classify vertical asymptotes. Now we're going to start with our function already in factored form. And you see that before you right here. And in particular, all of the information about the asymptotes comes from the denominator. So once it's factored, then what we do is we find the roots of the denominator. And of course, in factored form, it's easy to see that the roots of the denominator are x equals minus 1, x equals minus 1 again because it's a repeated root, and x equals 5. It's important that we pay attention to repeated roots because that will help us classify. But right there we can say we know where our vertical asymptotes are. And so we could actually put those in. We know we have a vertical asymptote at -1. So let's put in our vertical asymptote right there. And then we have a vertical asymptote at 5. Okay, so we've found the vertical asymptotes. Now we need to classify them. And remember, there are 4 things that can happen at a vertical asymptote. So let's draw in a couple examples here. Let's draw 4 vertical asymptotes. So near a vertical asymptote, there are 4 things that can happen. We can have the case where it goes up the left side and down the right side, or down the left side and up the right side. These two, notice the graph is going in opposite directions at the vertical asymptote. So we're going to classify these as being of opposite type. We can also have vertical asymptotes where the graph goes up on both the left and the right side to positive infinity, or down to negative infinity on both sides. And these are what we're going to refer to as the same type. And so that's what we mean by classification. Is our vertical asymptote of opposite type or same type? And the classification works like this. What you do is you look at the multiplicity of the root of the denominator. So again, let's look. Here's the root -1. It shows up twice. Its multiplicity is 2, which is an even number. And so if the multiplicity is even, then that particular vertical asymptote is going to be of the same type. So that means the graph is going to go up on both sides or down on both sides. We don't know which, but we know it's going to go in the same direction. Whereas if the root has an odd multiplicity, then we know that near that asymptote it's going to go up one side, the graph's going to go up one side and down the other side. We don't know which, right? We don't know which of these two cases is going to occur, but we know that it goes up one side and down the other side. And so we really can't draw in for this particular graph what's happening near near the asymptotes without more information. But we can classify them. So we know that -1, the asymptote at -1, because it has an even multiplicity, can be classified as being of same type. And then the asymptote at 5 can be classified as being opposite. So for instance, this may not be the case, but for instance, the graph could be going up and up, right? It's, as an example, it could be doing that. And then on this one, it might go down this side and up that side. Or you could swap those or have different combinations. But those may or may not be the cases, but that's what we mean. So that should help you find and classify vertical asymptotes.